First of all, thanks a lot to the organizers, Kevin and all others, for including this paper into the program. I realized that, this paper has been around for a while, so I realized a lot of people in this room have seen this paper already, so I apologize that you have to go through it all over again. This is joint work with Benjamin, who's in Zurich, and Mark, who has recently left academia. And what we want to do in this paper is to think about how the interplay between genetic endowments on the one hand and the quality of schools that children are exposed to shape the distribution of educational attainment in society. So why is that important, or why is that an interesting question to look at? Well, we know that education is very important for a lot of life outcomes that we care about, be it health, be it income, be it overall well-being. And for that reason, a lot of people have an interest in having educational systems, educational institutions that produce kind of like a distribution of educational attainment that complies with certain notions of equity that we might have. So for example, we want to have a society in which everybody has actually an equal shot of getting the educational attainment that they're striving for. Now, if we want to actually move educational institutions in this desired direction, that they comply with these notions of equity, of course, we need to have an appropriate understanding of the factors that shape the distribution of education attainment. So we want to understand the education production function. So if we want to think about that, and of course we know that education is co-determined by a lot of different things, among others, the genetic endowments that people might have, but also a lot of environmental factors or a lot of environments that people are exposed to, be it their home environment, so what parents are actually doing with their children, but also the schooling environments that their children are attending. And what we want to do in this paper is to understand a little bit better the interplay between those different factors. And to make this a little bit more precise, what we're after in answering here is the question of whether school resources or better schools are actually cushioning or magnifying the effects of genetic endowments on education attainment. Or alternatively, to give this question a slightly different twist, are schools actually able to correct for the outcomes of the genetic lottery or not? And we studied this question in a sample that has been already kindly introduced by John in his presentation in the EdHealth data set, which basically is a representative sample of high school students here in the US. And what we do find is that indeed it seems to be the case that schools in the US seem to be able to correct for the outcomes of the genetic lottery to some extent. So what we do find is that there seems to be substitutability between genetic endowments on the one hand and the quality of the schools that students are attending on the other hand. So what we find is that a 1 standard deviation increase in school quality actually decreases the impact of genetic endowments on years of education by approximately 17%. Now, whether substitutability here is a good thing or bad thing, of course, depends on who gains and who loses. And what we find here is actually that it is indeed driven, this pattern of substitutability, by the relative gains in educational attainment for those students that are further down in the distribution of genetic endowment. So it's especially those students with lower polygenic indices for education attainment that gain relative to their high PGI peers when attending schools that are of higher quality. And this substitutability actually arises in particular in the intermediate stages of the educational biography. So it's not necessarily the case that the substitutability arises at the stages of high school graduation. It's also not the case that better schools actually help those low PGI students to get a PhD or postgraduate degree, but it's really happening at the stages of college graduation. What we also see is that those substitutability patterns are actually underpinned by a number of skills or measures for skills that are highly predictive for education attainment. So we see that those low PGI students are actually gaining both in terms of measures of health, also in terms of cognitive skills, so in terms of their language ability, and a number of socio-emotional skills, such as here embodied by preferences such as patience and risk aversion. So how do we think about the contribution of this paper? There are two main literatures that we want to contribute to. Of course, on the one hand, there is this growing literature on gene-environment interplay, to which a lot of people in the room have actually contributed to. Here, at least to my reading of the literature, there has been a lot of attention to the interplay between genetic endowments and family environments on the one hand, so family socioeconomic status. And what we're doing here in this paper is that we kind of like take a stronger focus on the schooling environments and see how those schooling environments actually interact with genetic endowments in shaping the outcomes that we're interested in. On the other hand, we want to contribute to this literature on school quality, which is also very large. And here, basically, the main finding in this literature is that, of course, on average, more effective schools or schools of higher quality contribute to the educational attainment of students. But then there's also a question on who gains is in particular from attending better schools. So, for example, there's this recent paper by Carabo-Jackson and co-authors who shows for students here in Chicago that it's especially those students who are coming from a low SES background who tend to benefit in a particularly strong way from attending better schools in comparison to their high PGI peers. And what we're bringing to this literature is actually that we're looking at another dimension of heterogeneity here, which is heterogeneity by genetic predispositions of individuals, which might be, of course, a dimension of heterogeneity that is of particular importance if we think about an equal opportunity society. So this is the outline of the talk. What I would usually do now is kind of like introduce the measurement of genetic endowments. This has already been done by James. So in that sense, I will skip that here. And what I will just say is that what we're using in order to measure genetic endowments is actually the third edition of the polygenic index for education attainment, which is based on this GWAS that was already discussed, but that was published in 2018 in Nature, based on roughly 1.1 million people of European descent. So with that being said, let me directly jump to the analytical approach that we're adopting here. So what we have in mind is the following. Basically, once children are conceived, they're of course endowed with a certain amount of genetic endowments that are fixed across their life cycle. From the moment of their conception, they're basically also exposed to investments that are coming from different actors. So from basically the moment of conception, they're exposed to the things that parents do with them. So maybe certain behaviors of mothers and fathers during the pregnancy, but also after children are born, we might want to think about how often parents read to their children. We might want to think to what extent they're helping with their homework and so forth. So they're monetary and time investments that are basically happening in the private domain. So the things that parents do with their children. At some point of time, of course, also the public domain comes into the picture. So from age 6 on, children are also going to school and they're exposed basically to different schooling environments. You can think about all kinds of different things that are kind of like prevalent in the literature on education economics. You could think about better teachers. You could think about smaller student-teacher ratios and so forth that also co-determine the educational attainment of students. What we're interested in estimating is actually the cross derivative between, on the one hand, genetic endowments, and on the other hand, the schooling investments that children receive at a particular child age A, which is here embodied basically by this parameter kappa. How do we estimate kappa? So what we're doing is basically that we're regressing our measure for education attainment on a measure of genetic endowments, which is just the polygenic index for education attainment, and a measure for the quality of schools that children are attending. When I talk about the quality of schools that children are attending, we're thinking about high schools. So basically, we put a particular focus on child ages 14 to 18. So basically, when children are in high school. And of course, we want to estimate this parameter kappa, which is just the interaction between this index between the polygenic index and our measure for the quality of schools, while conditioning on a bunch of x's. Now, if you just look at this estimation model, of course, there are a number of identification challenges that immediately come to mind. So if we want to give our parameters here a causal interpretation, of course, what we would like to have is exogenous variation in our polygenic index. We can have exogenous variation in our polygenic index by thinking about, for example, sibling designs. We might also have data on genetic trios that allows us to explicitly condition on the genetic endowments of parents and so forth. In the absence of exogenous variation in our PGI, of course, our estimates might be confounded by something that is very well known in the existing literature, which is genetic nurture. The second thing that we would like to have is, of course, exogenous variation in our schooling environments. We can have that by means of various designs. We can think about admission lotteries. We can think about border discontinuities in terms of in school catchment areas and so forth. And in the absence of such exogenous variation, what we're susceptible to is something that is called a bias due to sorting into schools, right? So parents basically are choosing their schools, the schools for their children, and that might be something that is correlated with the socioeconomic status of families and so forth. In that sense, in absence of this exogenous variation in the school, in our measures for school quality, we're going to be susceptible to such biases. The last thing that we also want to have is, of course, that we want to have independent variation both in our polygenic index and in our measure for school quality. Why is that the case? Well, if basically all the high PGI students were clustering in the best schools, then of course we wouldn't be able to identify the parameters of interest in our model independently from each other, such that we would run into a problem of under-identification. Now, if you think about those three requirements jointly, it's of course, it illustrates that we're setting ourselves to a very tough task, right? So ideally, what we would like to have is basically, for example, a large sample of siblings for which we have individual data on their genetic endowments, and within those families, kind of like exogenous variation in the assignment of schools to those children within the family. To the best of our knowledge, there's no data set that basically ticks all those three boxes at the same time, such that we basically now have to rely very heavily on the access that we're using in order to take care of those potential biases that we're facing. Now, if you then run this model conditional on our access, of course, the causal interpretation for our parameters of interest comes with very strong identifying assumptions, right? Now, I don't ask you just to believe me that those identifying assumptions are satisfied in our setting. Instead, what we're doing in this paper, and what I will also try throughout this presentation, is to provide you with a bunch of statistical tests to convince you that those identifying assumptions conditional on our access are actually satisfied to a reasonable extent, such that we believe in the genuine nature of our estimates here. In terms of the data, what we're using, as I already hinted at, is the EdHealth data set. So basically, EdHealth starts with a nationally representative sample of students in grades 7 to 12, and that was collected in 1994, 1995. And those students have been followed basically until 2018, such that in the last wave of observation, basically we have information on individuals that are now in their mid-30s, such that it's reasonable to assume that they have completed their educational biographies. As is good practice in this literature, we also restrict this data sample to children that are of European descent genetically, which is due to the fact that this underlying GWAS for the PGI that we're using has been also calibrated on a sample of individuals of European descent. So what are now the data inputs that we're using in order to estimate our models? I told you already the PGI that we're using. I also told you about the educational outcomes that we're looking at. So what is kind of like of interest is, of course, how we measure school quality. But what we kind of like leverage here in the study is that EdHealth actually has administered questionnaires to the headmasters of the schools that are in the sample, which gives some information on schooling environments. But then also EdHealth has been linked to a bunch of administrative data sets, such as the common core of data, where we have additional information on the schooling environments that students are facing. So what we're using, or what we're taking from those two different sources, is information on the student-teacher ratio, the average class size, then two measures that are indicative of the experience that teachers have and on the turnaround that we see in terms of teachers at this particular school. So we have information on the share of teachers that have been at this particular school for less than a year, and information on teachers that have on the share of teachers that have been at this particular school for more than 5 years. Lastly, what we also have is information on the education attainment of teachers. And here we basically have a measure for the share of teachers in this particular school that have more than a master's degree, or at least a master's degree. We take this information now and construct measures for the school quality. And here there are two ways of how we aggregate those different dimensions of school quality. On the one hand, we run a principal component analysis where we basically extract the first factor as a measure for the quality of schools that the students are attending. And alternatively, we also use the linear aggregation method that was proposed by Anderson and Klingen-Katz in 2007. Another thing that is, of course, of interest is, since we're heavily relying on the access to do the job in terms of controlling for genetic nurture and for sorting into schools, is what are those access exactly? So on the one hand, we control for a large array of different predetermined characteristics at the family level and at the child level. So for example, we control, of course, for the education attainment of parents, both for mothers and for fathers. We also construct measures for their potential wages, which we basically also, where we also capture the variability of those wages across the life cycle of children from the ages from 0 to 14. We control also for the 21st principal components of the full matrix of genetics data in order to account for population stratification and so forth. We complement this large array of predetermined characteristics of the children and the families that we're looking at with a control function approach that was actually proposed in an AER paper by Altonji and Mansfield in 2018. And the idea here basically of this control function approach is that what they propose is basically that we can take account of sorting into neighborhoods or different schools by just controlling for a bunch of observable group characteristics, which according to their line of argument basically also takes care of controlling basically for sorting based on unobservable characteristics. So what we do basically is that we control at the school level a number of observable characteristics for the composition of those schools, which we calculate as leave cohort out measures in order to avoid any mechanical relations between the individual that we're looking at and those average measures that we calculate based on their peers. And I will tell you later on, or I will show you later on, whether this control function approach actually works in the setting that we're having here. So this is just a bunch of descriptive statistics for the sample that we're looking at. There are no big surprises. Let me just tell you that if we basically look at our sample and compare it also to larger data sets, basically based on the American Community Survey or based on the CPS, we can actually show that our sample, even after all the restrictions that we're imposing, is still representative. So there's no weird things going on in terms of the sample selection that we're imposing here. Okay, let me walk you through the results. So what I want to do first is kind of like to walk you, to convince you kind of like that those identifying assumptions that I've been discussing previously are reasonably satisfied in our setting before then taking you through the actual results with respect to the interplay between school environments and the genetic endowments of individuals. So what we're doing here is basically is that we're regressing, or that I show you correlations between our measure for education attainment, so years of education, regressed on our polygenic index. And on the left-hand side, you see this correlation basically without controls. And here you see that the one standard deviation increase in the polygenic index increases education attainment of students by roughly 0.6 years. We know that this correlation is, of course, susceptible to genetic nurture. So once we kind of like introduce all the axes that I've been talking about, this correlation shrinks significantly to a level of 0.36, which is basically consistent with what we would expect if there's genetic nurture in the data. Now, the question is, of course, are our axes sufficient to control for genetic nurture? And in order to kind of like get a hunch of that, we're making use of the fact that a subsample of our analysis is actually based on siblings. So what we're now doing is basically that we're running the same regression in the first column, just in our sibling sample, so regressing education attainment on our measure on our PGI while controlling for all the axes that I've been showing you previously. In the second column, we do exactly the same exercise, but now we're also conditioning for a family fixed effect, which of course helps us to control for genetic nurture. If after we condition on our axis, there was still scope for genetic nurture to confound our effects, we would expect that those two coefficients would be very different from each other. However, what we can show is that those two coefficients are actually very precisely estimated. At the same time, basically, if we run a statistical test in order to test for the equality of those coefficients, we cannot reject the equality of those coefficients at any meaningful level of statistical significance. And this, of course, gives us an indication that our axes are indeed able to account for genetic nurture in an extent that is very comparable to a sibling design, which then, of course, bestows some confidence that that genetic nurture is not large enough or any residual confounding due to genetic nurture is not large enough to overturn our main results. We can do the same exercise, or we can do the same exercise when looking at our measure for the education for our measure of school quality. here, basically, we see that a 1 standard deviation increase in our measure for school quality increases the educational attainment of students by roughly half a year. Once we take account of all the axes, including our control function approach, this relationship looks significantly flatter. So here, basically, we have a 1 standard deviation increase in the school quality measure, increases education attainment by merely 0.14 years of education. Are we doing a good job actually to account for sorting into schools? Here we basically run again as a test in order to see to what extent our control function approach is actually doing the job in terms of controlling for sorting into schools. And we do that as follows. What we're doing is basically that we're predicting years of education based on all the predetermined characteristics for family environments and child characteristics that we use normally for our controls. And then we run this regression of this measure for predicted years of education on our measure for school quality. That is what you see in the first column. What you see is that basically there's a strong correlation among the two, which is suggestive that there's indeed sorting into schools if we don't account for our control function approach. Now we do the same thing, but only account for our measures of observable group characteristics at the school level, so the variables that underpin our control function approach. And what we see there is that once we condition basically on those variables that are part of our control function approach, this correlation shrinks basically to zero. What we also see is that those coefficients are statistically significant from each other, which basically suggests to us that indeed our measures for that we use for the control function approach are doing a good job in terms of accounting for the fact that students are basically sorted into schools based on the socioeconomic background characteristics that they're having. So in that sense, selection to school also seems to be a concern that is reasonably well in checks once we have conditioned for the variables that are part of our control function approach. The last thing that we want to have is, of course, independent variation in our measures for genetic endowments and our measures for school quality. So what I plot here are just unconditionally the distributions of the PGI at different levels of or at different deciles of our measure of school quality. What you can see here is that those distributions are overlapping. There is no meaningful correlation as we go up the deciles of the school quality distribution. And this is something that holds unconditionally, and that also holds after we have conditioned it on all our axes. If you want to make this more formally, or this test more formal, we can also run kind of like pairwise Kolmogorov-Smirnov tests in order to test for the equality of all those distributions. And what we find there is basically that we can only reject the null hypothesis of equal distributions at those different deciles for 2 out of 45 of those comparisons at the 10% significance level, which is, of course, something that could be driven by chance. So in that sense, we also have sufficient independent variation in our measure for genetic endowments and school quality, which then kind of like ticks the last of the 3 boxes that we have in mind when thinking about the identification. Okay. Let me walk you through the results in terms of gene-environment interplay. So what you see here is basically now that it is still the case that a 1 standard deviation increase in the polygenic index increases educational attainment of students by roughly 0.36 years. We also see again this result that 1 standard deviation increase in our measure for school quality increases the educational attainment of students by roughly 0.12 or 13 years. And we see this negative interaction between school quality and the polygenic index. If you take the ratio between the 3rd row of this table with the 1st row of this table, you actually get the 17% in terms of substitutability as a headline finding that I have been outlining at the beginning of this presentation. This is actually a finding that doesn't depend on how we aggregate across those different dimensions of school quality that we have in mind. So basically, whether we take the PCA in order to construct this measure for school quality, or the Anderson method for linearly aggregating those different dimensions of school quality, actually doesn't matter for the results. Now, we can also decompose our index for school quality into its different dimensions. And what we see here is basically that those results that we find in terms of substitutability are very strongly driven by the educational credentials of the teachers that are active at a particular school. And the results are also strongly driven by the experience of teachers. So the more experienced teachers you have at your particular school, the more we find a substitutability pattern between the school quality and the polygenic index for individuals. What we do not find is that there's any of those substitutability patterns when it comes to the share of new teachers at the school and for the class size that we observe at a particular school. The question is, of course, still who gains and who loses. And in order to show you kind of like who gains and who loses, I bring you the following graph. What you see here in this graph is basically a prediction for education attainment for each different combination of the polygenic index on the y-axis and our measure of school quality on the x-axis. So how should you read this graph? If you look at students who are actually the most genetically advantaged, and we look at their predicted education attainment across the distribution of school quality, we actually see that they're going to have a high education attainment no matter what. So for them, it's really not so important what is the quality of the school that they're attending. If we now look at the students who are in the lower tails of the distribution of genetic advantage, we actually see that it looks very different. So for those students, it actually matters as we move horizontally across the school quality distribution. For them, it's actually important. For them, it actually means that if we move to a higher levels of school quality, that they are making jumps in terms of the education attainment that they're having. And this basically then underpins the finding that it's especially those students who are in the lower tails of the distribution of genetic advantage that they are gaining relatively stronger when actually attending schools that are of higher quality, whereas this is not the case for students that are in the higher areas of the distribution of genetic advantage. Now we do a bunch or like a large array of different robustness checks. And I would love to talk about in more detail about them, because in the end, like no matter what we throw kind of like at this relationship, this result holds. So we can think about including other school characteristics in our regressions. We can think about adding kind of like or expanding the extent to which we control for various family characteristics and also their interactions with the genetic endowment. We run placebo tests for different assignments into schools. We also kind of like cut our sample in terms of getting rid of outlier schools and so forth. But the results basically always hold. The results also hold if we correct for measurement error in our polygenic index. What I want to do in the last 2 or 3 minutes is to give you a little bit more of an intuition of the mechanisms that underpin our results. So what we're doing now is basically that we're running the same regression, but basically now we're looking at different measures of skills that are highly predictive of education attainment in order to get a sense of whether our results are actually driven by gains in particular scales or not. So what we do is basically in terms of the cognitive domain, we look at the picture vocabulary test as a measure of language ability. And we look at economic preferences, namely risk aversion and patience, as some notion of socio-emotional skills. And we also look at different measures of the health of individuals. And what we see here is really that those substitutability patterns that we're finding are driven both by relative gains of lower PGI students in terms of their cognitive development, also by actually decreasing their risk affinity and by increasing their patience, which is, of course, are all dimensions that have been shown to be highly predictive of education attainment. We also see that this substitutability pattern pops up when looking at subjective health. Just to kind of like, we also look at personality development of those students, and I can tell you basically without showing you the table that nothing in terms of substitutability pops up for the personality of students as measured by their Big 5 personality skills. At which stages of the educational biography are our findings actually popping up? So what we first show is kind of like something that has been shown in Kevin's and Nick's paper and Daniel's paper, and that has also been replicated in a study for Sweden recently, that if we look at the interaction between family socioeconomic status and genetic endowments, we actually see a pattern of increasing complementarity as people go through their educational biography. So basically there's an increasing complementarity starting from high school until basically they attain postgraduate degrees. If we contrast this pattern of family environments now with school environments, we see that the picture looks radically different. So here we actually have the case that we start with a small level of substitutability at the level of high schools, which increases basically at the stages of college education, whereas there's no substitutability to be found anymore when we look at postgraduate degrees. And this, of course, I mean, if you kind of like contrast those time series, or not time series, but those two series against each other, what this actually suggests is that relative to their high PGI peers, low PGI students tend to benefit to a stronger extent from actually going to higher quality schools than actually being exposed to a higher socioeconomic status of their families. Okay, what I want to leave you with is what we do in this paper. We analyze the interplay between genetic endowments and school quality. We find actually that there's a substitutability between higher quality schools and the genetic endowments that people have. And this substitutability is especially driven by the relative gains in terms of educational attainment of those students that are in the lower areas of the PGI distribution. Why does it actually matter? Well, this actually suggests that if we invest in schools, if we provide better schools to everyone, we actually might be able to play in the leveling field and get rid of some of the effects of the genetic lottery that people are exposed to. And with that being said, I look forward to the discussion by Chao and then also the general discussion.
Okay, thank you for having me here. And this is a very interesting paper and very important question as well. So do investment in school quality mitigate or magnify students in genetic endowments? So the authors use a very good data set that is well suited to study this question. And this is not an easy question to answer empirically because you have a lot of identification challenges. And I think the authors did very good and careful empirical work to address concerns about potential confounding factors. And then they found good news. The good news is good schools can help the genetically disadvantaged student without hurting those genetically advantaged students. So that's great. And leading to the toward the final educational attainments, the intermediate outcomes or the mechanisms are that schools can help the disadvantaged student in terms of their language ability, their patience, risk aversion, and okay. So, so the model they have in mind is this. So, before the kid was born, then everything, the skill development depends on genetics, and between age 1 and 5, it depends not only on the genetics and also the parent investment. Of course, skill development is cumulative. And then after the student go to school, it also depends on the quality of the school. That's IS, the investment in terms of school quality here. So then if you put it into the final education, then it will depend on the history of parental investment, history of schooling investment, and genetics. So then they run this regression in that framework where this PGI is the genetic propensity to attain education, and QI is the high school quality index based on teacher education, tenure, and the class size. And then the interest of the parameter of interest is this kappa here, the interaction between the PGI and school quality. And instead of thinking about parental investment as the previous model suggested, they have a whole bunch of predetermined parental and children characteristics in this regression. Okay, so the assumptions or the concerns that might lead to identification problem are these: you need exogenous variation in PGI, you need exogenous variation in school quality, and you also need independent variation in the school quality and PGI. So I would say based on the data they have at hand, the author did a very good job and do what is feasible to do in given the data situation. Okay, so the thing that I want to focus on is this third component here, this independent variation between genetic endowment and the QI. So if you remember, the author showed the distribution by deciles of the QI or the PGI. It seems to be independently distributed. These two variables seems to be independently distributed. And on the one hand, this is great news for what they want to do, because they do want independent variation between these two variables in order to run that regression. On the other hand, at least to me, this is very puzzling, because if you think about it, school quality is a choice, and PGI is measuring the student genetic propensity to education attainment. So then, at least to me, I would expect some sort of selection based on the selection into schools based on PGI, given the strong substitutability between school quality and PGI. So then the question is, why? Why there is no correlation, or there is so independently distributed? I can think about the following possible explanations. The first one is, well, parents don't know. They don't know their children's genetic predisposition as measured by PGI, or they don't react on it, even if they not know it. A second group of explanation is there are some frictions in school. So it could be that parents don't know about school quality. Could be that parents don't have good understanding of the production function, i.e. the substitutability between QS and the PGI. Or they know it, it's just their choices are constrained by certain frictions, institutional frictions. So why do I care? Why do I care the reason? Well, the first best, if we have the resources to improve school quality over the board, then it doesn't really matter which is the explanation. So, but on the other hand, if you do not have the resource to improve the school quality over the board, the second best is to improve the matching between student and the schools. And how do you achieve that? That depends on what is the underlying factor. So, for example, if it is a first factor, the parents don't know, or they do not react on it, I think this can be tested. For example, the authors have in the EdHealth data, there are student time investment. How much time you spend with your kids, what is the relationship between the kid and the parent? Those can be you can see whether or not that kind of investment seems to respond to PGI. If it does, then maybe factor A is not the main reason. Actually, in the previous literature, people have done some investigation in terms of how parents react to genetic endowment of their kids. And then I would like to see this tested in the EdHealth data. And in addition, at least to me, how parents' own investment react to their their children's PGI itself is very interesting. It's another aspect of nature versus nurture kind of story. Okay, so factor A, we can test it. Factor B, there could be some frictions in school choice. Suppose the first one is maybe parents are not aware of school quality. I think this might not be the main reason, because first of all, the school quality the authors are using are based on something that's easily observable, teacher turnover, teacher education, teacher experience, those are easily observable. And also selection into schools is well documented. Actually, this is one of the concerns the authors have to begin with. So maybe that's not the reason. Second reason is parents do not have a good understanding of the production function. For example, Flavio has a paper on that, and parents do not know much about how the effectiveness of their input into babies' development. And the third component, maybe parents know all of this. It's just that when they are choosing schools, they are constrained by institutional barriers. For example, school zone based school choice programs. So if that's the reason, you should do some school choice mechanism reform. If information is the reason, you should do information intervention. So then, so I want to make a note here because in the conclusion of the paper, the authors say, well, they are saying we should improve quality instead of promoting genetic screening. And I think giving reducing informational friction or institutional friction family face can facilitate their choices and even the playground. This is not genetic screening. So that's my most important comment. There are some other comments. The other thing, this is minor. I would like to see some other outcome measures, for example, math scores, because in the value-added literature, people tend to find teachers' effect on math is larger than on language. Another thing is, let's think about the model. Back to the model. The why, the outcome, is a function of a history of school environment and parental investment and genetics. So in this paper, the authors are interested in how the school environment interact with genetics in producing skills conditional on predetermined characteristics of the family and of the kids. And a very challenging but very interesting extension would be to bring back, according to the production function, bring back the parents' investment. So, and study the interaction of parent investment, school quality, and genetics. That will be a very interesting thing to do, but I realize that's hard. So that's all I have to say, and I learned a lot. Thank you.
Actually, I will. What I'm going to say will be close to the comment. The problem I have is you have a production function which is a where is it? Yeah, you have a production function which has many inputs, right? But you're looking at you look at the outcome and you look at the impact of two different inputs. What about the other inputs? So we've done some work on exactly trying to estimate production function. One thing we found is that A, parental investment is crucially important, and B, it's completely endogenous on everything. So if you don't control for parental investment, you're likely to have a very strong omitted variable bias. And if you control for it, you need to instrument it because it's endogenous. So how do you think about parental investment?
I think like the basic idea is in our baseline regressions, we don't want to control parental investments because it might be just a bad control in terms of what we're doing, right? So we basically rely on those predetermined characteristics to give a sufficient characterization of what the children can expect in terms of parental investments. Now, that being said, in one of the robustness tracks, we actually use the parental time investment indices that Charles has been talking about and introduce them as additional controls, being aware that they might be bad controls. But introducing that as additional controls, also interactive with genetic endowments, doesn't change at all the results that we find with respect to the interaction between schooling environments and genetic endowments of the students. So in that sense, I would say that kind of like what we're finding there is robust student concern that you're having there.
Hey, Jonathan. Just in terms of the interaction effect you estimate. If I understood well, you just like basically interact like the bonus score with the school quality. The school quality, despite different linear control for selection of that school quality, still capture some other variables, like parental, so SES and so on. I mean, so, and some of these, well, okay, I guess that's what I'm concerned, but like usually the way I've seen G by E studies and the way is, control for this, you also control the controls linearly, and then you interact with control with the score, and you well,
You do that.
you do
So
that.
if we do it in one of the robustness checks that I haven't shown you, it doesn't change at all,
Okay.
I think, in terms of the coefficients that we're estimating. We're kind of like starting parsimoniously because our data is rather small, but then we're kind of like trying to see to what extent we can push the data by including all the interactions between all the measures for predetermined family socioeconomic background characteristics that we have in mind, interacted with both the measure of school quality and the polygenic indices, also even kind of like taking account of higher order polynomials in terms of school quality and the PGI adoption.
Dick has a problem. Dick.
So I guess first, a comment or maybe a supposition. I also work in kind of GI environment studies, and there's a bunch of them. I start to wonder whether these interactions that we are estimating are fixed. I think actually they're sort of policy mutable, or maybe it depends on what we mean by school quality. And so that's just kind of a comment that I start to wonder whether we should be pushing a little bit more on under what conditions and in which contexts, and depending on which measurements of quality do we have a G by E that's complementary or is one. And then I guess when I start to think about the policy modifiability of G by E directions or signs, I wonder what we want, because here I think that you framed it as a correction, and I think Chow also said like this is good news, but I mean why do we think this is good news? I mean, it seems like nice to say kids with a low polygenic score for no fault of their own are gonna, do better in school if you give them a nice school. But if you look at school funding in the US, we certainly don't fund schools in that way, giving more to the disadvantaged. Now that might be terrible, but it also might be because kids with more resources do better. And so, it's more bang for your buck. So I just wonder why we're kind of having this immediate reaction that like, this is good. Maybe it's terrible. Maybe this is a total waste of resources, right? I don't know. That's it.
I mean, can I respond to that?
Oh, please. That's all I have to say.
I completely agree. I mean, this is not like what we're finding here is not saying that we definitely should do it, because basically the framing that we adopt here is really from an equity perspective, right? It doesn't talk at all about the efficiency of how the money is being used, right?
Yeah.
So in that sense, if we think that equity is super important and that genetic endowments are an important factor that we should think about from an equity perspective, then you might want to adopt this. If you're concerned about that, rather the money should go actually to those students who kind of like who are already genetically advantaged, because you kind of expect kind of like that there might be a complementarity, whatever, in terms of providing the next Einstein who is going to contribute a lot to the greater good of society. Of course, then this is not what you want to pursue. But again, I mean, this is kind of like really framed from an equity perspective, and it doesn't say that this is based on that already. And like the definite thing should do as a policymaker.
Could you show us the distribution within it?
That is correct. Yeah, but I mean, there could be also other characteristics of students that we might expect kind of like this possible.
Well, Q,
Yeah. When I saw the heat map you showed, I saw the story it was going to be a stealing map. Because if a kid has high PGI, even if the person goes to bad school, you still finish college, right? But the metric doesn't quantify whether they still benefit from going to a better school because it's bad. But in a later slide, you showed that you look into this, it's not significant. I was just wondering why that's not your opinion.
Why it's not because we don't see kind of like that this substitutability pops up at the higher stage of educational attainment, right? So basically for postgraduate degrees, it's not there anymore, which suggests that it's basically not due to the fact that the distribution of education attainment is kind of from above, right? There is the sufficient leeway also for students to go further in the education attainment, which suggests that in the end, it's not due to the fact that there might be some.
But isn't that contradicting with the map? Maybe I'm just not getting the point. Because if you look at the tail of the PGI distribution,
Yeah.
kids with very high score, they finish college, they go to postgraduate degree no matter what, right? But if you have a way to quantify if they have better achievement beyond that, don't you expect to see weaker interactions?
I wouldn't know why you would expect that. Maybe it's, yeah, I'm not sure where you're getting, but let's talk about it afterwards. Yeah.
Before I reallocate, I just want to jump in. I don't know that it's everyone at the top end of that tail goes to college.
No,
Maybe it's
that's
maybe like 60%. I mean,
Yeah.
I think maybe for a true ceiling effect, you might need much higher
Yeah.
fractions that are in there. That's still, I think, an actionable margin even for kids that are way out in the tail, the right tail of the PGI.
How highly correlated is the PG score with the measures of ability, say IQ or something? If it's IQ, then it is virtually 100%. But I don't know.
There are definitely people in this room that know that number. I understand. I don't know off the top of my head, but
Is there a high score, for example, the high score that he was using in particular correlated with a high measure of ability, even an achievement test like AFQT?
Was the
I don't know what the correlation is.
So,
yeah.
based on the 2018 polygenic score for years of education, that accounts, depending on the validation sample, from 7 to 10% of the variance in IQ.
I'm sorry, in terms, but I'm just looking at the ranking.
Uh-huh.
So I'm saying if I'm at the top decile of the AFQT, am I at the top decile of this polygenic score? There's no student. I don't know. I'm asking. You're the expert.
The answer is no. There's much more regression to me than that.
Surprising. What is it measuring? It isn't measuring ability then in some sense.
sorry, I didn't mean to. Okay, conversation. Sorry.
I think it's correlated, but it's not one to one.
No, but it's kind of surprising, isn't it? We do know that if we were to use IQ or some achievement scores, we get very high relationship. It's just surprising to me that these scores aren't that highly correlated. It just leads me to ask, what are these
The
things?
polygenic score is not a perfect measure of what you might call the true polygenic score, because all the weights in the polygenic score are subject to sampling errors
Sure, I
in
understand.
the trainings you want.
Sure.
Furthermore, I guess the way we put it is that the genetic correlation between IQ and years of education, though high, is well short of 1, and so that's another reason not to expect it to predict.
It's pretty high rank. If you get to the top deciles of IQ, you're almost certain that somebody's going to graduate high school from you. And you may not get a PhD, but you'll certainly get a high school degree and many go to college. That I know. I don't know anything about polygenic scores, but I do know. I'm really asking the questions, what is the polygenic score measuring? It's not measuring its kind of ability.
Well, there has been some research into, well, what is GWAS of years of education measuring other than IQ? Sometimes they call it residual non-cognitive skills or something like that. And there's been some interesting correlations found between that component and various other trends.
And we have two more questions from hands that were still up. So we'll go to Bosch, and then we'll go to John, and then we'll.
Oh, no, you wanted as well. Yep. Hold on.
Yeah, so I didn't get into this question of Jim's, but I had a separate point, which was, I actually found, I would have thought the measures of school quality are pretty close. And that might, I'm thinking maybe you're just, understating that. If there's some way to kind of correlate your measures with sort of other kind of more refined measures of school quality to sort of see if this should even be inflated. I'll just quickly say on the IQ PGS thing, there is evidence that IQ is moved by environmental stuff. So it's not obvious to me that it's purely the genetics. So that's another reason PGS should be necessarily as highly correlated.
The main reason that PGS is not super highly correlated with IQ, I think, is, as James said, just lots of measurement error. the GS right now.
You can correct for that, right?
Yeah,
There were a
well-
lot of studies that did that. And what do you find when you do correct
I
measurement?
mean, how do you correct? I mean, you can instrument.
Don't you have some measures of the measurement there? I don't know.
Well, yeah, no, there's way, like, for instance, if you have there's GI.
Standard methods, you know.
Yeah,
correct.
I don't know, yeah, there are ways, yeah, you can instrument one score
Right,
itself,
okay.
like measure it into split samples.
Sure.
And then I don't know what what you get from that. Presumably you get something similar, you're supposed to get snipper ability.
I'm gonna show that actually.
Okay.
What are you gonna show us?
The application of the genetic instrumental variable, to
Okay.
the cousins, to the measurement error correction in the cousins. And the difference between what you get forward and after.
Substantial.
You're gonna make us wait?
Tell us what, give us a preview.
Well, the precision improves and the error decreases, but it's not a lot. It still remains consistent with the OLS.
But also the scores are based on common SNPs only. So there's lots of variance. So basically, I'll never explain all of the genetics of IQ because not based on the current SNPs we have, because this SNP we measure or not the full genome. Well, we have sequencing that out. The bugs store are based on genotyping and computer genotyping. So you wouldn't expect them.
John, we're waiting patiently.
Okay, no problem. Yeah, I was intrigued by the result that the lowest PGI students would benefit the most by going to better schools. Can you break that down as how much is peer effects? How much is it the better teachers or something other effect?
I mean, the way we're controlling for the key effects in view of the control function tools that we're using, we're kind of like controlling gradient position. So basically, how we interpret these things is like everything that we're seeing there is basically those school policy effects that are factored in terms of the teachers that they're having, in terms of the payment of those teachers, and the students that those teachers are having. So in a way, kind of like we interpret this really school policy.
Yeah, I'd just like to mention, there's an article in the Conmetro by Bruce Sackerdale. They did an experiment at the West Point Academy to try to use peer effects and, put low ability students with high ones, and it actually backfired. And, they were expecting a positive peer effect, but the kids mixed like oil and water, and it actually hurt the low ability students to be matched that way. So the question is, you get into a group that's like too high, you get psyched out or something like that.
Yeah. I mean, we don't see that, at least for the interaction between the many ones that we're having and those measures for the quality of the kids that they're having, but basically the all interaction curves there come out with the space zero, which is not consistent with this one.
I think Bosch is right, the quality measures using.
Very
coarse. They're very coarse.
very coarse. We have
And we know that if you have like mentoring with individual students, you can get very substantial benefits.
Yeah.
And that's tailored much more to the individual. Your measures are not at all tailored. It's like,
they are super coarse. We actually wanted to kind of like using the data that we're having, wanted to also kind of like construct measures of school value added and so forth, but the data is just not suitable for that. So right now I'm working on a follow-up project where kind of like we go in this direction based on a different data set, but this is for the future and not feasible with the data that we're using.
Right, to those,